Really excited to be here today to talk about this new feature that we've delivered on our TrafficLink Performance Measures product, our intersection health feature. First and foremost, today's focus is going to be all about this new feature that we're delivering to our customers and the market, but we can't do that without providing a little bit of context, a little bit of insight and history into ATSPMs. How did we get to where we are today, and why is this so relevant in today's world? From there, I'll pass it over to Sajjad, who's going to give everyone a quick rundown on the feature, get into the weeds of it, show you some of the functionality, and importantly, we're also going to be demoing this live in the TrafficLink portal because it's always better to see the tool in action within the actual software solution rather than just seeing some static slides. And as promised, we'll end the webinar off with a question and answer period. So please do throw those questions into the bridge. You know, it wasn't too long ago where folks like yourselves, traffic engineers, you were fairly limited in the tools that you had at your disposal to go about solving problems in your traffic networks. With the exception of the traditional signal retiming study, you know, if you wanted to remedy citizen complaints, if you wanted to tend to congestion issues, if you wanted to tend to citizen complaints, you really didn't have much in your arsenal to go about solving those problems. And for those of you who have followed the lore of ATSPMs for some time, you know that the traditional signal retiming study in general has its limitations. You know, first and foremost, you're collecting data, you're doing these retiming studies on a cadence of every 3 to 5 years. It's a very, very long time frame to go between these retiming studies, especially if we consider all these changes in urbanization within our cities. Alongside that, you're usually tending to problems based off of the citizen that's complaining the loudest. Now, while that's a good way to make the problems go away and citizen complaints are a source of data, we know that they're not hardened ground truth. If you add into the mix some of the other constraints with this method, you're usually collecting very small subsets of data that are used to inform long-term changes. You're going to take that data, punt it into a software that's going to hypothetically model characteristics at your intersection. And then just for good measure, you're not going to conduct an after analysis to see whether or not the changes that you made had the intended impacts. And so when ATSPMs came along, they really did prove to be this fundamental shift in traffic operations. And it's a testament to IoT technology and investments into sensor technology, where we went from having this very linear, elongated approach to measuring demand, modeling traffic, evaluating, and then improving performance, to having a much more cyclical, iterative approach where we had constant data coming in that we could use to tweak changes within our traffic network. And the great thing about ATSPM data is that it was coming from existing infrastructure. We already had infrastructure out in the field that would facilitate the usage of ATSPMs. So we were using high resolution signal phasing information from our traffic controllers, combining that with detector activations, both the stop bar as well as advanced detection, and also throwing travel time into the mix. All of these data sources combined to generate ATSPMs. If we move on to the next slide, Sajjad, ATSPMs essentially gave traffic operations teams complete visibility into the actual performance of their traffic networks. So when it came down to doing those retiming studies, you could actually use the ATSPM data to target your worst offenders rather than the intersections that were just up in queue from the 3 to 5 year cadence. But if we take it a step further, ATSPM data, because it's so granular, because it provided such a high fidelity medium of showing you everything that was going on in your network, you could actually use it to drill into latent issues within the network that could have been causing congestion that may not have been able to been fixed through a traditional signal retiming study. And of course, all of this was in service of an objectives-driven approach to signal retiming within a municipality. This is where we are today. Over time, what we've noticed, especially in talking to our customers, is that there's been a little bit of a shift in the problems that our customers in the market are experiencing. Early on, the problem was all around, I don't have data. I don't have insight. I don't have visibility. I don't know what's going on. Where we are today, it's as if the pendulum has swung completely to the other side. And the problems that we're hearing from the market are that hey, there's too much data in front of us. There's too much insight. There's just too much being thrown at us. And I mean, in theory, ATSPMs are a fantastic solution. We know that, right? They provide a lot of value to customers. However, what we've come to realize is that there's certain T's and C's, certain requirements that need to be in place in order for municipalities to successfully maximize the effectiveness of ATSPMs. Some of the things that we've heard from our customers, first and foremost, ATSPMs are hard, right? It's a fairly technical product. There's a significant amount of domain expertise and training that's required to successfully adopt ATSPMs and interpret the data that you're reading. And despite the best efforts of the FHWA through their Everyday Counts program and their innovation initiatives, many provinces and states have not fully institutionalized ATSPMs as of now. The second thing that we often hear from our customers, in addition to ATSPMs being hard, is that they're time consuming. Right? There's so much data. The current state of products is that you really do need to mine and sift through so much data to find those insights. It's like looking for a needle in a haystack. And we know that many traffic teams are already resource constrained. They're already treading water. Asking them to mine for these insights, to sift through data, to find that one important piece of information that could have an impact on their network, the ROI really just isn't there from a time perspective. And the last thing that we often hear from our customers is that ATSPM didn't really live up to the billing of being proactive. They were touted as this proactive approach to traffic management, but because they're so hard, because they're so time consuming, we really haven't been able to get ahead of citizen complaints.
So Sal gave a pretty great intro into how the data is collected, how the massive data is coming in, and what kind of problems it can potentially solve. But although the data is super useful, but it requires a lot of time and dedicated resources in order to be able to really produce value out of it. And this is coming from experience for myself in the past more than 4 years that I've been working directly with the ATSPM data with hundreds of agencies, hundreds of intersections. This was very clear. It is very time consuming if you want to proactively identify issues on a large scale of, I don't know, hundreds of intersections. It is very difficult to be able to sift through all of that data to be able to identify problems. If something's really, if you know something very specific, you can sort of go in and target it, and look into the data in a very targeted way. But we wanted to make sure that we are creating some intelligent engines that would help sort of reveal these kind of inefficiencies automatically, and so the user or the engineers or the agencies can think about solution generation, not spend their time on sifting through the data. So the data would work for you, not you working for the data. I need to emphasize as well too that this is a functionality that is included in our ATSPM offering at no extra charge. So if you are already a customer of ours and you have an account with us, this will be available at no extra charge. If you're a new customer or you're interested in this, to clarify, this is a part of our basic ATSPM offering. It just comes with our ATSPM solution. So really, in this version, we wanted to target a number of problems, and we were sort of looking to what kind of problems are customers looking to be able to surface automatically. And we took a data-driven approach towards this. I'll later on explain sort of what the data was. But the idea here is that we are identifying 3 major issues that we have seen to be quite prevalent and quite common in the intersections that we've been installed at. And these are sort of problems that traffic engineers and analysts, they are familiar with these kind of issues. So first one is suboptimal green splits. So cases where there's an imbalance in performance. The second one is phase termination issues. So when minor movements are not terminating properly, or they're extending the time for no reason and creating wasted green time, and poor coordination. So if we are identifying that coordination isn't really optimal and the green bands aren't aren't determined in an optimal way, we identify and surface those issues. I want to clarify that the approach that we're taking is a traffic engineering approach towards these problems. So we're not simply identifying we're not simply setting some kind of threshold and we're identifying a problem based off of that. We are identifying problems within the context of the ring barrier diagram, for example. So for example, if we have data from the ATSPM data that is providing us with information on the performance of all these different competing movements throughout the day, different time of day plans, and we're looking into the problems in the context of the sequences and the concurrency of the phases, and not just one movement is having a significantly high amount of split failures and we're just reporting on it, because that means nothing, to be honest. Or if there's a movement that is having a lot of force offs or a lot of max outs, what does that even mean? Like, can I even do something about that? That's the big question, right? We don't want to surface issues that really the intersection is operating in an optimal manner and there's not much that can be done about it. We want to be able to surface issues that you can actually do something about the problem. So definitely there's a lot of science going on in the background of this to be able to identify these problems in a very efficient way and not to sort of bombard you with useless information. So as I said, we've took a data-driven approach towards identifying these three problems that we've started on version 1, which is just the start of it. But I personally have evaluated the more than 200 intersections. This was a paper that we presented in last year's ITS America conference, and surprisingly, these three problems are quite common in a lot of agencies. So about 50% of the intersections that we evaluated had some kind of suboptimal green split that could have been addressed. 38% had phase termination issues, and 41% of the corridors were impacted by some kind of suboptimal configuration that was causing poor coordination. So this is just the start of it. Version 1, we're targeting these problems, and as you can see, like, it's just a matter of adding more sort of problems and working with our customers, working with the industry, people in the industry, and be able to surface the problems that they want to see. For example, level of service, corridor level of service, intersection level of service, and that sort of thing. So just to give you, before I go into the demo, I want to explain what these three problems are in just a little bit more detail. So suboptimal green splits, again, when there is an imbalance in performance between competing movements, we identify that in a specific hour and we report on it. And this needs to be a problem that's happening as a trend. So it's just happened. So if it just happened one day or it was sort of an anomaly, we're not identifying it. We identify trends based on crunching multiple weeks of data, and if it's a systemic issue, we surface it. So this would be a case, for example, that I would say that this is a very common complaint that we've heard from public agencies that they receive, is that I've been waiting behind this signal for multiple cycles, but the other direction isn't as busy. Why do I need to wait so much? So this exactly identifies that. If there are cases where one movement is experiencing a higher level of saturation compared to others, and there's an opportunity to be able to shave some time off from the competing movements in order to be able to address the issue, we surface that. The second problem that we identify is a phase termination issue. This is actually surprisingly common that I've seen, where minor movements that are actually actuated do not terminate properly. So they waste screen time. They cause a lot of delay for the major movement. So for example, left turn movements on the major that need to be serviced, extended, and terminated do not terminate properly and waste screen time. This could be either due to very high minimum greens. Sometimes it's due to high passage times. Sometimes it's just a recall and no one knows about it. So there could be a variety of reasons that I've seen that this could be happening. So if that's the case, and we're identifying that a minor movement is having this situation where it's wasting green time, we alert on it. And then the third problem that we're identifying, poor coordination. I think everyone's familiar with that. When the platoons of vehicles aren't able to smoothly traverse along the corridor, in corridors where that definitely is the objective. And if using the green band data, if we are identifying that that those green bands in both directions, so we're not just considering one direction, if both direction are not are suboptimal and not producing the optimal green bands, we alert on it and surface it to our users in the software. So here we will jump into the exciting part, which is the demo. I'm demoing one of the accounts with their permission that have kindly provided us with the permission to be able to use their account. So just to showcase, so performance measure, I think pretty much if anyone has seen any type of ATSPM system, there's these number of performance measures that are produced. We have other webinars and we have a lot of content that we'll later on share as well too, that if you'd like to know more about the general ATSPMs and what they are and everything. But the idea here is that it's always ask and receive, right? So you need to know what you're looking for. You click on a specific performance measure. You exactly need to know what time and day you're looking and sort of dig into that data. Definitely very valuable, suitable for its own application. What I want to show today is the intersection health capability, where we are automatically surfacing these problems that I talked about. So you will see a map view of your network, all the intersections that we are providing software. You can see the intersections that are performing well based on the criteria that I explained, and the intersections that are experiencing issues. So if there is an intersection that is experiencing an issue, we surface that, and you can actually see it, and you have the option to click on it. So if I'm seeing this intersection that is experiencing suboptimal green time, either through the list or through on the map, I can click on it, and it will take me to another page where it will now provide me with the more detailed insight into what's going on at this intersection. So as you could see, this intersection is experiencing suboptimal green speed, so that's the problem. When is it happening? It's happening PM weekdays and PM weekends. So this is a problem that's happening during these two times. So we're narrowing it down for you. And then we're also indicating the movement that's suffering. So in this case, the southbound left turn movement is the one that we are highlighting here. Why is it being highlighted? Because as you could see here, these are the categories that you can see on the screen. The description are provided below. This is a typical ATSPM performance measure. We're using stop bar detector information. We can classify the performance of a specific movement. So using occupancy information. So for example, if a specific movement like this left turn has cycles where the detector is constantly occupied during the green, and just at the start of the red, there's still vehicles remaining that haven't been able to clear the queue. We detect those. We classify the category first, that's a split failure that's happening. And then we do that for all the competing movements at the intersection. So as I'm scrolling on these movements on the map, you can see that it highlights it on the list view, and it's providing that performance information. So as you can see, there is no movement at this intersection that is experiencing split failures as much as this southbound left turn movement. So this SF category is split failures, and that 20% is telling me that 20% of the cycles during this time, PM weekdays, are experiencing split failures during this hour. You also have the option to dig in more. So if you want to interested in sort of being able to exactly see what's going on, how much green time is that left turn getting, and all of that information, you can click on that specific performance measure and investigate more. But this is where sort of would be your main page, where it's surfacing this information to you on a regular cadence and providing you with information. So this was an example of a screen split issue. Another example could be a phase termination issue. So when I'm clicking on this, I can look at this, and I'm seeing that, for example, in this case, the southbound and northbound movement, which appear to be minors in this case and actuated, they are experiencing a significant amount of spare capacity. So 70%, 95%, 95% of these movements, again, they're happening concurrently, and we are assessing them in a concurrent manner. So it's not just we're assessing them separately. We are assessing them in the context of the ring barrier diagram and considering the concurrency. And considering that concurrency, we are seeing that this movement is wasting a lot of green time. So this now allows the user to either go into our dashboard, into our performance measures, and be able to figure out, okay, why is this movement wasting so much green time? Could be a passage time issue, could be a minimum green, and easily be able to produce a solution around this and be able to address the problem. So this is the view again. This is just the start of the problems that we're identifying, and we're hoping to be able to add more problems and problems that you are interested in, and be able to provide the ability to be able to filter the types of problems as well too, and be able to showcase that. So I just wanted to provide a short demo of this new feature. Again, if you have an account with us, our customer success will be in contact with you to be able to sort of educate you and show you the new functionality. And it is included in the ATSPM base ATSPM package that you have with no extra cost.
I just wanted to remind everyone here at Miovision, we like to think of ourselves as the smartphone of the intersection. We have hardware that gets deployed throughout our customers' network. It's permanently installed in the traffic cabinet. And once you have our hardware, it's a really modular approach to unlocking additional software applications that can provide value for your team or even adjacent team members. Of course, the conversation today was heavily revolving around our performance measures product, but we also have a signal management solution, which is geared for traffic operations, as well as signal technicians, using infrastructural data to flag maintenance and operational issues so that you can streamline your workflow. Our video detection solution, which is incredibly robust courtesy of our computer vision computer vision offerings, and we have stop bar detection. Safety analytics, using proactive surrogate safety measures to help your teams identify those unsafe intersections in your network to prevent fatalities and collisions from happening, or well, fatalities. And last but not least, continuous counts. This is the permanent fixture of our Scout line of business, if you will. Again, leveraging our computer vision capabilities, providing 24/7, 365 multimodal turning movement counts. So in summation, 3 key takeaways for today's webinar. First and foremost, intersection health is a feature addition to our existing TrafficLink performance measures product. So for our current customers, as Sajjad had mentioned, your Miovision representative will slowly start reaching out to you, and we're going to be rolling this out to our customers. But for new customers and prospects who are interested in a performance measures solution, just know that this is part of our base offering, and the purpose of this is it's designed to help you save time, make ATSPMs easier to use, and ultimately take us a step closer to taking that proactive approach for traffic operations. In our current iteration, we're able to surface those 3 problems that Sajjad had mentioned: the phase termination issues, green split issues, as well as poor coordination. And the approach that we're taking with all of this problem identification is heavily rooted in a combination of data science queries as well as traffic engineering principles. So we're looking at the context of the intersection, understanding the sequential and concurrent operation, and marrying that with the continuous ATSPM data that we're generating. This goes beyond just threshold-based calculations. There's a lot of data science work behind the scenes to ensure that the problems that we're surfacing are actually relevant problems for our users. If you want more information, Shannon, thank you for posting that link in the chat window. You can visit our website and check out our performance measures solution page. And in addition, we have a lot of other resources. I think it was the first or second poll question. A lot of folks had mentioned, there's a gap in training. There's a lack of education around ATSPMs, which is a barrier for you to use them. Really happy to announce that we actually have a great ebook authored by Mr. Sajjad Sharavi on the line and it's a free resource for you. It's our take on how you can best operationalize ATSPMs, and we go through several different examples of how we've helped our customers. It is a free ebook. Feel free to go ahead and download it. You can also attend our Clear Signals 101 certification. It's an educational seminar where we run our customers through our approach to ATSPMs. So you can imagine, I'm taking some online courses right now. You can imagine Clear Signals, the ebook is the textbook, and then Clear Signals 101 is the in-class lecture. It's a quick certification, and it's been very well received by a lot of our customers. And I'm excited to announce Clear Signals 102 is coming out in November. So we've had overwhelming demand for Clear Signals 101, and we're going to continue to add some content to another iteration of that course. And I should reiterate, these are all free modules. So the ebook as well as the courses are all completely free. First question up, I'm seeing, do I need to have Miovision detection for this? So John, I'm going to take this one. So no, you do not need to have our detection solution. We are an interoperable product. So if you have other sources of detection, other vendors, whether it's loops or pucks or even video detection, we are able to ingest that data through our ATSPM solution and provide you some of these insights. Another question that I'm seeing here, are there plans to provide recommendations to actually fix issues? This person's thinking like a product manager, so John, maybe you want to answer that question.
For sure. Thank you for that question. Yeah, absolutely, right. So this is just a start. I guess we can't produce a recommendation or a solution without actually identifying a problem. So sort of starting off with the problem space and being able to identify those different types of issues, and then we are actively working on being able to produce recommendations, as well as to provide you the tools that you need all in one space using 24/7 data, continuous data, in order to be able to address the issue as well too.
All right, and so John, I've got another one for you. This one's asking about the types of data, the actual ATSPMs being used for some of the problem. What metrics are you using to identify the problem? So I think the question's getting at, for the 3 problems that we have identified, like what ATSPM data are we actually using to service them?
Right. So the data that we're using for that, one of the main ones is the split failure data. So using occupancy data, one of the Purdue's methods of classifying the performance of different movements at an intersection is using stop bar occupancy and correlating that with the green time, which would be green occupancy ratio, and the first 5 seconds of red, and then classifying different cycles. So that's one of the main sources of data, which is coming from the stop bar data. That's why you don't really require a specific hardware related to Miovision. If you already have stop bar detector from any other technology, that data would be available. And then the progression quality is coming from just the signal phasing and timing information. So we're taking that, we're lining that up, and we're creating the green bands on both directions, and we are assessing the quality of that green band. And if we are identifying that it's either very inconsistent or it's very low, we alert on that. So basically, stop bar detector and signal phasing and timing that's coming from the controller would be required in order to have this functionality.
Awesome. And I think you had mentioned, like, and forgive me if I didn't hear, but for the poor coordination, we're looking at specifically the time space diagram and the green bands, correct?
That is correct. So for the third problem, or the progression quality, it's based on the time space diagram.
And that's all I'm seeing. So I guess with that, we'll wrap things up. Thank you everyone once again for tuning into the webinar. It's always a pleasure to jump on the line and share knowledge with everyone. We look forward to keeping the conversation going. You've all got our contact information. We're your Miovision representatives. If you have feedback, if you want to learn more, if you have ideas, Sajad and I are more than happy to jump on a call. because this is the stuff that really gives us a lot of energy, which is working with our customers, working with our markets. So once again, thank you for tuning into the webinar, and we'll catch you next time.